There we go.
Good morning, everyone, and welcome back to Signals and Symptoms podcast. Today we have an amazing physician, guest over here, Dr. Nayan Patel. He has been working on an amazing product, which is essentially what we call contactless vital signs through his company called Natera. And one of the things that we explore within these podcasts is how things in terms of technology in general, and more importantly, how we're generating quality data that goes into AI and helps physicians through a clinical decision support system as well. Nayan is here in Dallas. We met at a conference where we were both speakers or co-speakers, and then he told me about his amazing work, and I was wanting to explore that. He has been in healthcare CIO for approximately 30 years. So he has a wealth of knowledge that we're going to go ahead and explore that. I apologize for a mucky introduction, but Nayan is going to do a much better job than I would. And then lastly, of course, very happy to see my besties, Harvey Castro, the space man that has more to do with so many things that I cannot believe. And Ed, by the way, feel free to give your personal updates, your travels, and everything, because I see a lot of LinkedIn posts from you, and I just didn't have time to coalesce that into a proper system. So before anything, Dr. Nayan Patel, are you a doctor? I forget.
I am not a physician, so
You're not a physician,
But when he
more-
stays at
more than
Holiday Inn, he is.
love it. So just to remind everyone, we do believe now that we need domain expertise from physicians, but honestly, in this age of AI, implementation, integrations of these technologies into real world experience is the largest bottleneck. And Nayan can speak about his experience through it. Of course, now he has his own new product line which, as well. So we're going to talk all of it with him. So without further ado, Nayan, again, I apologize for a choppy introduction, but go ahead and introduce yourself, your experience, your journey, and then Natera, which of course is mind-boggling.
sure. So my name is Nayan Patel, and hello Harvey, hello Ed. Good to see you all again. We're old
Same.
friends, so we're longtime acquaintances. Ed and I particularly go way back. I think we've shared many conversations together. Yeah, I've been in healthcare for a number of years. Last 20 have been specifically here in the Dallas area with large healthcare systems like Baylor Scott and White. I was running two of their heart hospitals from a CIO standpoint. Since then, I've done some interim work, interim IT leadership, interim CIO work, working at hospitals like Baptist Health in Jacksonville, South Texas Hospital, as well as a central Georgia hospital in a rural Georgia. So I've had what I call large hospital experience, medium hospital experience, as well as individual small rural hospital experience. And that has given me exposure to, many of the challenges that we face in our healthcare system. There are certainly many things that we can talk about, but the key thing that I think I'll point out today is there is no right answer to everything, and we live in a very complicated world of healthcare. So, our organizations of healthcare, many of them have thousands of applications. They're big enterprise systems, right? And so these things are, even in the smallest hospital, have hundreds of applications. And we're dealing with hundreds of vendors, multiple cloud vendors as well. We're dealing with, different type of security challenges that we have, and security things that happen even multiple times at the same time without not necessarily looking at it. And then you have AI that's being put on top of all of this, right? So, we're all trying to improve healthcare, but at the same time keep it safe. So that's a challenge for us. And when I say improve healthcare, and my tagline is about improving lives with data, right? And so that's where I'm at now. So earlier this year, back in January, I joined Natera. Natera makes a contactless vitals monitoring system. And what it looks like is this device here. You might be able to kind of see it. It's no bigger than a deck of cards, and essentially it's radar. It's high frequency radar. It's a motion sensor, and it uses fixed radar technology. I have one actually pointed at me right now on a tripod. So it is monitoring my heart rate, my respiratory rate, inhale.
Where's my device? I'm just
and it's
it's
nice.
a clinical grade, by the way. So just to use difference between Apple Watch and Google Fit, Harvey, you need to show your rings and everything as well. Huge difference between consumer. You have, so as compared to that. So distinguish that for the audience as well. That what is clinical grade versus consumer grade means.
Yeah, so we are relying on actions that clinical staff will be taking. So we have to get FDA Class 2 cleared for this medical device. This is not something that you can just start reporting data without it being, having certain level of qualifications. So yeah, it's one of the things that we try to explain to people, how does this technology work? I actually call it the early versions of a Star Trek tricorder. I mean, we're literally pointing something at you. You're not wearing anything. There's nothing to charge. There's nothing to, even clean in that sense. Once the device is there, it's monitoring people within the range. Essentially, think of it as a flashlight or a cone going out 30 degrees and 8 feet. And if you're in that range, we're going to detect these the vitals that we talked about. It detects them by micro movement on your skin. So every human body is electrical and mechanical. And we essentially map an ECG to a BCG. So everybody knows what an ECG is. A BCG is a ballistocardiograph. And essentially we are tracking those micro movements on your skin, through your chest, and basically it goes through clothing and bedding as well. And that's how we are able to map that and accurately track heart rate, respiratory rate, inhale exhale ratio, and sleep and motion data. So I think what it really comes down to is this is one more thing that we're trying to do to improve healthcare, to reduce the nursing burden that's happening. They don't have to now manually check vitals. We can do this. And it helps the patients too, because they're not wearing anything. Let me pause there. I know I said quite a bit there.
You did amazing work in introductions, and I have so many questions, including how do you compare with so many different, and we're going to come to it. But before I do, I want you to also, more importantly for our audience, explore more on the use cases. Specifically, I'm an ICU physician, and vital monitoring is an annoying issue. And then Harvey is an emergency medicine physician. And then you talked about nursing workload, but for me, of course, vitals monitoring is extremely important. Subarachnoid hemorrhage, I need to keep the blood pressure between this and this. So same thing with the ED, pulse oximetry for a person coming with severe pneumonia, intubate, no intubate, sort of make it more useful for me. And then of course go back to actually an ICU nurse, an ED nurse, and how exactly your technology is going to improve their workflow. And then of course we'll move to Harvey.
Yeah, so I think in the emergency medicine case, I'd love to say we have blood pressure. We're not FDA cleared for that yet. We're trying to work with a couple of hospital systems right now and do an efficacy study so that we can do that. And get that also in there, but we are not there. We're probably another 1 to 2 years out from that.
So for a software, or a physical device or SAMD, you just need to show non-inferiority, correct? Nothing more than that. Is that my assumption correct?
Yeah, I mean, I think what we're trying to do is we're trying to identify trends in something that's happening to a body. And in the case of emergency medicine, the specific use case that we are deploying actually this next month is in an ED itself. So we've installed our device into ED waiting room chairs. And so this is pretty cool. So in those cases, we're actually, instead of an 8-foot window, when it's installed in the chair, it's going 2 to 8 inches of whoever's sitting in that chair. And so the typical use cases, and hopefully some of you have seen the PIT, And if you ever watch the pit, the use cases, there's several use cases that are technology related in that show, and they are going to drive the influence of technology for sure. But one of the specific use cases is somebody passes away in the ED, right, while they're waiting. And so the one hospital approached us specifically and said, hey, could your technology help us with this type of situation? And that's how this use case got created. So we put this device in the chair. We got a medical furniture manufacturer to, build it out, configure it, and now we have these chairs available. And the goal is that if a patient is in the four walls of any hospital healthcare system, they feel that they're responsible for that body, right? And so we are working through the logistics on the workflow and the notifications. But essentially, if there's somebody sitting in a chair now and we see their heart rate drop below 50, below 40, whatever, something that says, hey, something's happening to that person's body, we can send an alert to whoever the nearest nurse or nurse call system that's there to, basically escalate a situation, say somebody in that chair needs attention. We can't, we don't have a lot of specific, that's when they'll put real telemetry on that person or get that person addressed right away, instead of somebody sitting there for a long time and you didn't know an adverse event happened. So that's the specific use case related to ED, that we're able to passively monitor somebody and they don't even know they're being monitored in that sense. But we would let them know that we are watching you or something to that effect. So we're working through the healthcare organization. And once we get it deployed, we'll certainly be talking more about that.
Amazing work. I'm going to start with Harvey first. Harvey, what are your thoughts, questions, and then we'll move to Ed.
Yeah, number one, I guess the FDA will obviously do that. I'm curious how much of within margin of error are the ranges of the heart rate of all the parameters you're taking. I'm just curious.
Yeah. So we actually monitor, we collect the data every second, and then we trend it, and we have a dashboard that we report at every 5 minutes to show kind of where your heart rate is at. It's a 95% accuracy right now, and it's going to be higher than that once you're trending it, right? So, if you're getting it 95%, in 1 minute or 5 minutes, you can imagine the number of data points. We collect thousands of data points that are, because we can detect your heart rate, as an example, through your hand, through your leg, as well as your chest cavity. It's, there are many things that give us that data. And so we're correlating all this data, and it's collecting it. I mentioned to you that I have the device on a tripod for testing purposes, and I monitor myself. And I had it next to my bed as well, and I positioned the cone so that it just monitored where I was sleeping versus, a second person like my wife. But it only picks me up because of the way I positioned it. And during the evening, it's collecting roughly 42 to 45,000 data points every night for that 8-hour, 9-hour period that I'm there. And so that's the type of data that we're collecting. And then that's when we are able to present the heart rate, inhale, exhale ratio. Respiratory rate is probably the biggest one, because what we're able to see is how there's a strong correlation between respiratory rate and pulse ox. And, that's something that is, and now there's a correlation between that and blood pressure as well. Like that is, respiratory rate is a big signal indicator of what, if somebody needs attention. So there's a lot of data being collected. So on the order, it's probably 100,000 data points per day is what it'd be collecting. But then what do we need to present? What are we really trying to do? And I think one of the biggest challenges is we don't want too many alerts, right? You got already too many bells and whistles happening in an environment. What's really important? So we can talk
especially about the industry term is alarm fatigue.
Yeah,
absolutely.
So
are actually good. Yeah. Ed, before I jump onto you and your question, I want to give you, the audience and you, a little bit of clinical sort of background. So there's a book called ICU, John Moreno, which is considered Bible of ICU. And then one of the lines in that is that of all the things we do in healthcare, blood pressure is the least accurate. And you will not believe like how crazy it is, because we used to do blood pressure through manual cuff. Then there
Right.
is automation blood pressure cuff. Then there is Artline, and now of course your solutions, which including some of these solutions that are coming. So blood pressure has always been a problem, and then of course vitals in general is extremely important. And then you need to figure out the trend, because the trend is more important than that. Just to remind you people that we had a study on sepsis. Uh, of course, COVID data really, freaked out, but clinical decision support system modules were released. I was able to detect 15 minutes early, which is insane. That I can actually give them a fluid bolus. I can give them, uh, you know, um, fluid bolus, art lines, intubations, etc. So 15-minute window was huge. I mean, I can actually literally, support everything because of the trending. So vitals are that important as far as this is concerned. Even just to give you another clinical data point, you can have a person who does not require intubations, but if the trend is actually getting worse in terms of respiratory rate and pneumothorax, if you give antibiotic 1 hour early, you decrease the rate of admission in a hospital by 30%, you decrease the rate of ICU admission by 10%, you decrease the rate of death by 1%. So again, I just want to make sure that everyone understand clinically that how important vital monitoring is. And now I want to tell you the problem statement. The problem statement is that the patient is encephalopathic. He's just disoriented, takes out the blood pressure cuff. How many times can a nurse walk in and put the blood pressure cuff? Then the nurse has to come in to make sure that the pulse oximeter, which is such a garbage issue, no matter how many times, it always slips away. And then, so now that's the problem statement, that we do need what his technology means, 8 inches or somewhere between 8 inches to 8 feet away, to be able to trend for me. So now you understand the problem statements that we have. So I just want everyone to understand that why I'm excited about what Nayan is doing. And just having said that, just giving you the clinical picture. Ed, on to you.
No, that really makes the point and the purpose even more clear, and why this is a great solution. And I also put in the comments for everyone Nayan's LinkedIn profile, because he produces a blog. It's pretty much every Friday, right, Nayan? You're dropping once a week.
Every other Friday, roughly.
Every other Friday. It's called The Glass is Full. It's really good. Yeah. You should definitely follow and check out good food for thought on a Friday. So yeah, why not? So I love it, right? And to your point earlier, from a tech point of view or administrative point of view, you can save a lot of money because you're consolidating a lot of point solutions into one, and you're continuously expanding it. Why not consumer? Like, why can't? Yeah.
We're ready. Home health is the next target market. Everybody asked me, and I had the same question, honestly, when I was going through the interview process. I said, hey, can I use this for my mother-in-law? Right? She's in an apartment by herself, senior living. She's not in assisted care or any kind of real monitoring, right? So, and she didn't want a camera in her house. So that's the best thing about this thing. There's no privacy issues with this thing too. There's no data, there's no visual or audio data being collected of any kind. And so, yeah, home health is definitely a big target market for us. We need to do more studies with how to get it deployed. So we are doing a pilot with a large healthcare system that does oncology and hematology patients that they're sending 30 patients home with our device. And so again, part of that is to validate how that would look in a home environment. And as I mentioned to you, that I have it on a tripod, that's what we're sending it to them on a patient's, with putting it on a tripod. And it doesn't require anything except USB-C for power. So it's only power, and then everything else is through Wi-Fi, or in the case what we're doing this with the home health patients is putting it a hotspot connected to it. So it's all pre-programmed, and you just put it in, and it's just got to be positioned that you're in that ice cream window, a flashlight window of 8 feet, right? And so there's more testing required and validation before we deploy it to a home health market, because there's a lot more logistics and coordination to figure out when you're trying to put it in the home market. But definitely that's a long-term plan for us in the next few years.
Yeah, because I know you deal with it, Janae deals with it. You know, we all have relatives like over in India or Pakistan, and we're the physicians, right? Simran is the clinician for thousands of people in these remote villages, and it's kind of hard, right? You don't have a lot of data, but imagine if they all had access to this sensor. You know, it would change the game, and she could be much more precise in providing sort of medical advice. And obviously, that's a very small use case, but we could all extrapolate what that would mean.
It's a huge use case because everyone I talk to talks about, managing elderly parents or uncles or relatives or friends even. And in the case, my mother-in-law lives about 25 minutes away, 20 or 25 minutes. It'd be nice. And out of the gate, there's no programming required. We have texting and email notifications just built into the dashboard. So all you got to do is just set up your phone number and email. That's it. I had to turn off my texting because every time I got out of the range, we also get what we call a bed exit notification. So like, okay, it doesn't need to tell me every time I get out of the range. But I kept the email enabled, so I know that it's working, right?
Yeah.
And so yeah, there's the big thing though for me is not so much I want to track my mother-in-law's movement, but if her heart rate goes below a certain amount or above a certain amount, and there's a trending threshold. I think, Junaid, you mentioned, being able to see trending through time. So we can set it up that, within an hour, if your heart rate average dropped 10%, okay, there's probably something happening to you, or maybe it's 15% or 20%, whatever the right variable is. That's where we rely on you to tell us what threshold you want to set. And then we can send those alerts, and they can go to whomever. So that's where clinicians really appreciate it because they're only getting alerts on what they define as critical or important.
Again, I just want to clarify a few things. We can do pulse ox heart rate monitoring here, but just want to be very careful. They have AFib monitoring, which is a big issue for, big belly genetics like mine coming from India, Pakistan, and Nepal, the SAARC countries. The difference is that number one, I cannot sleep with an Apple Watch. That's why I got this, which I can't sleep with it either. I just can't. And then, so we need something that is not touching my body overnight. And that's extremely important. Not to mention that one AFib case detected out of 100, we can now treat it with a medication called apixaban, which is actually equivalent to an aspirin. So long story short, you have a proper pathway moving forward of detecting it. And not to mention, of course, that overall cost, if the patient gets a stroke or a cardiac myopathy or anything, millions of dollars downstream can be saved by early detection, not to mention. And then not only that, this is, of course, again, more clinically grade, FDA approved, etc. And we are moving from what we call screening devices, which could be these, to verification devices, which I already do, quote unquote, prescribe a Holter monitor or, implantable loop recorders. I don't know what's going to happen to that. So, but long story short, then we are coming to the next phase of it, is essentially continuous monitoring. So again, clarifying the use cases in terms of clinicians and, as Ed said, commercialization of this as a wellness device and not just as a health tech device is kind of important. I have one question, but before I ask Harvey, do you have something in your mind?
No, there's so much. This is great. My curiosity, because I've been helping some companies with this, is what do you think of the competition? I know the space is huge. What do you think of other companies that are further along than you guys?
So there's certain companies that have been trying to figure out a good solution for this, and including where they've got, I'll call it pads or sensors that they put in the beds, and the reality is the accuracy of ours is so much better than theirs. And there's one particular company that's been, ahead of us in terms of marketing, but good thing for us is they're failing and then their customers are coming to us. So we're just going to let that ride out however it does, because the accuracy of our data is very good. And we're taking the right approach with the right clinical use cases. One of the challenges also you have with the ones that are in the bed, again, it doesn't require anything to wear, but you do have to clean that device. It's moving around, right? There's some different challenges there. And ours is a fixed device. Typically in patient rooms or like in long-term care facilities, we've got over 40,000 devices deployed in long-term care facilities or skilled nursing facilities or SNFs, right? And in those, it's just a fixed radar. We mount it on the wall behind the patient's bed. And so because it's not attached, there's nothing to clean, nothing to wear, and it's always wired on. It's not battery operated. It's specifically designed for ease of use in that sense. So there are other competitors in the market, but none that work like what we do. And one thing I did fail to mention is, how did we come up here? How did we get here? The technology is based on what you've probably already sensed with autonomous cars, right? So detecting motion with cars and, being able to, you see all the self-driving cars that are out there. That radar technology is what led to this, where we fine-tuned it to get that micro movement, skin movement.
Amazing. So here's my question. So now this is a real problem to solve, and then I don't believe in one technology, and I do believe in backups as well.
Yeah.
Whenever I have an art line, the nurses will take out the blood pressure cuff, and I said, "What the hell are you doing? You still need the blood pressure cuff because art line can fail." Massive issues. We are looking at this, and Artline is actually showing real blood pressures, which are fake apparently sometimes. So we just need to understand exactly how these things proceed in terms of this. So from a technology perspective, we have the spectrum. The spectrum is the general pulse oximetry, the green light that shows up. Then we have the heart rate monitors, which are both EKG, and then you have now ultrasounds that are coming, which again, we can talk about this. And then lastly, you use the word radar technology. Now, from a pure technological perspective, and I understand that all of these are going to mature, but as more and more data comes, the AI analysis also improves. The real thing that we need, again, I just want to remind everyone that if the blood pressure is low, 90/60, there are athletes who are running, including Ed. Probably his blood pressure goes low and he's cycling the whole world. While my blood pressure goes low to Ed's blood pressure, I'm going to faint. So the question of the absolute numbers is completely off. The whole point is trending, and that's where the AI comes in. So question number one, I understand the contactless part. Explain a little more about this radar thing. Again, not delves into intellectual property, but people can understand why it is important in terms of moving through the clothes as well, because that's sort of kind of important, especially for my population, which are demented, paralyzed, neurology patients as well. Then go to the second part, the radar part. Then do we enhance it, or do we have a pathway for your company to enhance the data from, let's say, Apple Watch, and use that to correlate and improve? And then the third path and the final path is that how do you see this being deployed in we talked about consumer and ED, but how do you see this currently deployed in the hospital systems, augmenting their current massive Philips, Siemens, all of this, and how do you push that information in as well, rather than just another dashboard for me to review? Do you understand what the problem is?
Yeah.
And I already have freaking alarm fatigue. I'm not gonna oh my God, now I have to check another system.
Yeah. Let me address the last one for you first, because as a CIO for hospitals, that's the first thing that, I said, listen, our dashboard is great. You need it for setup, but beyond that, that's it. The rest should be the alerting communication, should be whatever the system currently uses, a nurse call system of some sort, right? Most things are using some version of Rollin Responder 5 or whatever it might be. There's already systems that are being used. There's the devices that the nurses all hold too, right? The Voceras or the SpectraLinks, the Zebra phones. So use what's already there, and all we need to do is send an alert to the existing systems. We have HL7 feeds already capable, right? 2.3, 2.5. we're working on that FHIR integration as well. So we already are able to receive from whatever EMR that's in place. But we definitely don't want another pathway or another item that nurses have to go look at, right? So I think that's the first thing that I would say. Minimize, one more system. Now, yes, we're adding another system in the environment, but that doesn't help you in terms of the clinical workflow and the fatigue that's associated with it. So that's the first thing I would say. Your first question, then, I'm trying to go back now. What was the first question?
So the technology of pulse oximetry, where EKGs, and then now radar, and then also comment as an expert in the field about home-based ultrasound or even continuous ultrasound monitoring in the future potentially.
Yeah. So I mean, we definitely are trying to balance, with all the other tech that's already out there. And this is where we're working with some of the healthcare system to say, okay, this technology is awesome. I mean, it's cool technology, but how does it either supplement or potentially replace what you're doing today? So it's going to take time to roll it out in that sense. In terms of, being able to go through clothing and bedding, the reason why that's critically important is because there's nothing to wear, nothing to charge, and people are going to wear whatever they're going to wear. You can't control that. So we had to do a lot of testing to make sure it can accurately detect that type of movement. So that's the first thing. It has to be able to pick up that signal in the data, and then we have to be able to trend it or report on it accurately when we talked about making sure it's 95%. The next thing is then like these different use cases that you're kind of talking about. And not only, we talked about the ED, and we've talked about home health. I mean, there's so many different things. And so we're trying to figure out what are the right use cases that supplement the nursing workflow, not take and potentially replace if possible. I think we talked about respiratory rate is actually a proxy for pulse ox. And so we're going to work with a hospital system to do an IRB to really try to do an efficacy study to see if that can be validated. Because if that's the case, now you've got this contactless way of really, providing data that physicians and clinicians rely upon. The other use case that I wanted to mention was you meant the nighttime monitoring. You don't have to wake up a patient now every 4 hours to do a vitals check, right? That is part of a routine if you're in a facility. And this will just constantly monitor and the data is reported. The question is, and same thing here, we're working through the hospitals, what do you want us to report? Because we can send you don't need 100,000 data points to send to an EMR. You really just want to say, maybe it's a snapshot every 2 hours, every 4 hours. Here's what the heart rate average has been. And then you can send that to the EMR if that is relevant. Or is that also just unnecessary collection of too much data and then maybe only put in the trending threshold alerts? So we're working through, without adding too much information and more, I'll call it non-useful information, right? It has to be useful and something that's going to be clinically impacting. So those are a couple more use cases, and I can give in just a couple of more there. But
I mean, if I get equity stocks, I'll give you more use cases.
yeah.
So one of the simple things is that we always and I'm gonna finish here, is that pain is considered the fifth vital sign. Now the problem really is that at some point in time we have to figure out as clinicians, is this real pain or not? And then one of the things that we can see is at some point in time with your training and everything, hopefully, that do we use narcotics or even not sub-narcotics like tramadol and stuff? And then heart rate, respiratory rate, overall can be a significant impact for us, because a person in pain will have other vital signatures, with pain as one of them, don't get me wrong. But I'm just saying that one of the things that we can do this is also for chronic pain patients, because government is cracking down on not giving narcotics, but then I cannot help my patients either, because we don't want to get into surgery or back surgery for no reason because the patient is going through 3 months of physical therapy, steroid injections, all of that. So, when the patient pops a pill, which can be also connected to your device through an electronic pill box of oxycodone, and then you can review those through your device of how it impacts not just the vitals, etc. So I'm expecting some shares, but long story short, what I'm saying is that there are so many multiple use cases for an FDA approved device that can actually help clinicians actually help patients. Again, there are multiple ways to do so, and I'm grateful that you are open to understanding that technology, like anything else, is on a spectrum, and we can use multiple devices together to trend it as nothing else. So, Hari, back to you again.
Yeah, big picture, good job, man. I'm with Ed. I'd love to see this in the consumer side, obviously in the elderly. I do some work in Singapore, and they're really heavy on longevity, and they know that the crunch of providers and for the healthcare system are diminishing and the population's aging. So tools like this will help us give better care. So I'm really curious, are you looking also at international markets?
Yeah, we actually are in Europe. The company is actually based out of Europe. So we have a whole market for Europe and Asia as well. Starting off with the US, I think, is where we can, show a lot of data. And because we've already deployed it in many of these long-term care facilities, one of the key things that we did is we did an efficacy study for 4 months monitoring 612 patients that were in the bed. And what it produced was that 77% of the time, 5 days in advance, we could predict an adverse event happening. So because of the trending data, we're collecting all this data and we see what they're doing. So, and that's the same thing that we're applying into other markets as well. But again, it's about these long-term care elderly patients. That's the easy market for us right now. Home health is going to be, something where we have, because it's a fixed radar. That's one of the, I won't say limiting, but it's a different technology. It's not like it's moving around. It requires you to kind of generally be still, or at least being able to capture it when you're, like it's not going to check it when you're running. Like that's not what our app does or in our capability. The other thing that we can also detect, and Junaid, since you had mentioned about pain, I think that was a great idea. I mean, I would figure out a study to go do that. Like, I don't know how we would, but I'm sure there's some correlation there that we could work on. But we are already doing sleep studies, and that correlate to potentially pressure injuries, right? So, or pressure also called pressure injuries. So we're trying to do the analysis that says if the patients are not moving every 4 hours, we can send an alert, right? Or every 2 hours, whatever it is, they need to be moving if they're at risk for any kind of pressure injuries. So there's
especially after stroke patients that are paralyzed, that would be amazing.
Yeah, so that's one element as well. And then, sleep score. We actually do give you a sleep score now. So it basically how much you're moving, because we're able to just easily track that. This is just, if you're sleeping well, we can see how much REM sleep you had too. So there's all kinds of data associated with that. And then the second piece that I wanted to mention was arrhythmia. You mentioned that earlier. So we will have arrhythmia as an FDA cleared thing at some point. That's going through the process right now. So we're going to have that as one of our releases I'll say in the next year, hopefully.
So about 15 years ago, I was in the neuro ICU, and we had to get an ultrasound machine that was $75,000 and required an 8-month to 9-month process to get approval from finance and everyone to get one for the ICU. And then, of course, 3 months later, Butterfly came in with a $5,000 device that I was using it myself. And we have seen this progression moving forward. And I just want to make sure that audience understands what I mean by that. What I mean by that is that if I'm a true steward of healthcare and also healthcare finances, which, by the way, nobody reimburses me for it, and I'm just going to be very honest with you, that is one of the biggest reasons that the healthcare costs is runaway, because the person who's stewarding it doesn't care, because I'm worried about defensive medicine. But coming back to the point that we have screening devices Then we have verification devices, which is your technology, also on top of that. And then before I even call the patient to the ED, urgent care, or the hospital for an admission, where do you see evolution of ultrasound, home-based ultrasound? By the way, there are now robots who can just do whole echocardiogram through ultrasound, and as an evolution of what we call a monitoring spectrum and paradigm, from screening to verification to localization to pathways like admissions or further, CTA, heart, or whatever, imaging, etc. So where do you place ultrasound in there? I don't know how to place it. I just want your opinion and your expert opinion.
Yeah, no, I think it's one more piece of the puzzle, right? I mean, we talked about, or I mentioned it earlier, when you think of the Star Trek tricorder, we all remember this. Like, you just point it and it does this whole full body scan and it gives you all kinds of information. So it's one more piece that, if we can implement that technology, and we'll continue to get better and better, right? We're going to be able to find different things that our technology will do, and it may supplement, ultrasound too, because again, I can't speak too much about ultrasound. I'm not an expert in there, but I understand the core concept behind it, right? I mean, it detects the same kind of thing. It's detecting motion and by sound waves. And if there's a way to map and correlate the two, why would you not want to, right? So this is just one more piece that we'd have to look at.
The radar is amazing in the sense of away from the patient, and then ability to use sound essentially at the end of the day. While the ultrasound brings more contact, jelly, and all of that, but it localizes exactly as well. So if you say that the arrhythmia is it generating from the left atrium, the left ventricle, or whatever? So I get more information
Right.
Before even doing that. And then when I'm prescribing something that has everything as a risk, if I walk outside the road, I mean, I'm going to get a risk of, getting hit by a motor vehicle accident. What I'm saying is that risk stratification actually changes my game in terms of prescription without examination, because now I have so much data. I have screening data, then I have radar data, now I have localized data from an ultrasound, and therefore producing it. And this brings us to the last problem that I have. Seems to be that it's just everything is freaking developing in a isolation environment, and that's always the point. And actually, you should clarify this. Like, do you feel? And I did just for now, given the whole geopolitical inflation, actually, and the whole mindset of humanity itself within the last 5 years, post-COVID, has changed from less, maybe I'm wrong, sharing to protectionism. And of course, healthcare always had that goddamn problem, and now I think it's it's on steroids. I don't know. At first, comment on my stupid assumptions, if I'm actually assumption is correct. And Nayan, what is your overall innovation, sharing, collaboration attitude, given that you are a CIO of a hospital as well? So both of you can comment on it.
Well, Junaid, I would agree with you, but I'm going to defer to Nayan's expertise. But interoperability has always been an issue, and that's why the government's getting so much involved and trying to set up rules and regulations to encourage companies to share, but they always find ways around it. Yeah, I'm not a big fan. I think we could do much better.
Yeah, and I think from our end, one of the key things is protecting the data and the PHI side of it, right? So we actually provide that, I'll say, ownership to the healthcare organization. Ours is really just a device data. Like, we're saying, this is what our device is reporting. How you correlate it to a patient, we're just giving you essentially anonymized data. And then if you're attaching this to a patient, then it becomes the organization who is making that step. So we don't want to necessarily get in that game, because there's already complications there that the healthcare organizations have to deal with. So we're kind of leaving it up to them. They're going to continue to play with that as much as possible. And our goal is to just, as much as possible, be agnostic to that situation and protect the PHI, because we're really it's very device dependent. And, when you're rotating this device between multiple patients, then it's saying, okay, at this point in time, whoever was in that range or patient or the home device, that's who the patient was. But 6 months from now, somebody else is going to be in there. So you have to. That goes back to the healthcare organization and what they're doing with the data. We're providing and sending that data to the organization. However they want to use it is their challenge. And the other thing you mentioned earlier was just how things are kind of going, and more technology is being put in place. I'm sure you've seen camera technologies as well. Every bed is being able to be retrofitted with these great, all kinds of integrated systems. And, we're actually working with a couple of what we call innovation centers or transformation centers. There's 2 across the US right now, and one of them in the medical district in Houston, right? So we're going to show our device how it supplements other things, right? Because camera can't detect vitals, okay? They can help with motion and different things, right? But they can't do vitals. They can't do temperature. You still need,
I just want to clarify for the audience. There are people who are actually calling the camera, and then they're on the telemedicine. They're trying to report a lot of shit. By the way, just to let you know, this is all garbage. There is really no real camera technology. I have tested it. People are saying they're going to use it for phone cameras for vitals. Does not work. Just be careful with it. And I completely agree with you. As a clinician, I'm backing you up with that claim. I just everyone to understand that limitation. Maybe it's going to go away. Maybe we're going to have LiDARs on the phones, which, by the way, LiDAR is essentially a radar.
Yeah.
Just to remind everyone. And of course, cameras that can, do not retinoscopy, but something that will look at it. So we're looking at some of these things. Me and Harvey share new innovation technologies coming, but at this point in time, it is not clinical grade, or I do not see right now in the next year or so to be clinical grade. Things are changing so fast that I cannot see beyond a year anymore. So
yeah, I'm going to jump in real quick. So to your point, yes, as a doctor, we look at trends. Now, the accuracy versus trends are 2 different things, but we're looking at trends. If my heart rate is 100, but the accuracy is between 80 and say 110, yeah, that's big. But if there's a sudden change that it went from say 40 to 50, now it's 70 to 80 or 90 because its range is off, it's still showing me the trend. And to your point, the cameras are having now, a lot of phones are adding LiDAR to them so that you're able to optimize. As an experiment, I bought this little robot, and I'm going to make sure that the robot, I'm able to look at different algorithms are out there. I'm going to add it to this robot. I'm going to put it right here next to the computer. Now, I could use this camera, but I think it'd be kind of cool to just use this thing. And I'm going to do kind of these things. I'm going to check my vitals, checking trends, I did one for dermatology that looks at my skins and tells me how hydrated I am, how well I'm doing. And then it gives me my, I hacked it into my cloud Apple-based photos. And I know you guys are like, God, Harvey, don't do that. But it's analyzing, and it looked at the last 15 years of pictures of myself. And then it gave me a range of what my skin looked like, how I age, what time period in my life I aged quicker, and what time period I actually did not age as much and went the other way. So just kind of food for thought. If I could do this, then in the future, it'll be just every day on your computer.
Yeah, that's amazing.
Man, you need to send a device pronto to him so he can collect data for you. The Harvey, and by the way, just to let everyone know, we still sometimes, assume that Harvey is not human and probably an AI robot himself. The amount of stuff that comes out of this guy is insane. Anyways, I have, first of all, man, I'm grateful that you are doing this here in Dallas. So anyone who wants to do, we're going to hopefully set up another luncheon for all of our prior guests, especially in Dallas, and then go from there. Now, last few episodes, and this is probably the last question, we got another amazing innovator who built Savvy, which is essentially accessing my health information through different healthcare systems and making it easy. And I missed that. I mean, I reviewed the whole podcast later, and then you said that we want to give the data, and this is not something, and to the quote unquote healthcare organization, which is now an overall debate. You don't have to comment on your particular device and the current status. But what are your thoughts? And all three of you, who should own the medical data? Is it the patient, the healthcare system, the EHR? And then, of course, there's an intellectual property issue, because when I generated a node, it's my node. Why does why does the healthcare organization or even the freaking patient owns it? So it's just like and Ed, you may be able to sort of help me in other industries, or Harvey in other industries, when this multi-dimensional stakeholdership with stakeholder contribution. How do you decide the ownership?
So I don't know, Ed, you want to go at that first, because he addressed that to you. So, and you're on mute.
Yeah. By the way, I learned from him more than. Go ahead.
No, the government should own it. No, I'm just kidding.
Are you a Texan or what? I'm just kidding.
No, I believe, as a Texan especially, I believe that the individual owns the data. So I mean, it's not flat. Yeah, everyone should own their own data. So, I mean, if you had to pick one, that's my pick. Obviously, there's nuances like you talked about, Junaid, where you're using your IP, your technology, so why should someone else benefit? But ultimately, at the end of the day, we all know the key. I love monitoring. I love everything we talk about. But at the end of the day, the biggest difference maker is the personal decisions people make on a daily basis. What am I going to eat? What am I going to drink? Am I going to exercise? So it doesn't matter, right? Monitoring is important for sure. I love it. But the main thing is personal accountability. So if we can make people responsible or interested in their own data, and they own their data, I think they're more likely to therefore become engaged in their own health. So I think that's kind of the main reason why I would put it on the patient to own the data.
Yeah, I think
Harvey,
go ahead, that's definitely been a challenge. The magic question, I mean, that question is asked all the time: who owns the data? And there's just never been one right answer that can be put out, because there's so many different scenarios of the types of data that's out there, right? I mean, if you have any issue of any kind, you're visiting multiple organizations, multiple systems, multiple vendors could be involved, and there's data going in different places. I agree with Ed, though. I mean, it's really the patient's data at the end of the day, but there's different types of data. Like you said, a physician note, well, that physician is the one who is that's a different type of data. That's not a vitals data, so that's actually an analysis made on the patient, right? So there's different types of data, and even then that should be okay. Dr. Kalia said this is what he said about me and my health, so isn't that my data now? Like, this is about me still, right? So there are challenges around that, but governing that is where it becomes a big challenge, because there's too many variables and too many data streams that are out there.
I'm going to close today with the last question to Dr. Harvey Castro, my bestie as well. Harvey, you're essentially building a digital twin of yourself, and you're constantly experimenting with all these new monitoring technologies, also getting all your data into one place, and not just about the skin, 6 different devices, your electronic health records, etc. So comment on the last two things. Number one, how do you see moving forward? Are you going to do echocardiograms on yourself on a regular basis or not? So how do you see that evolution of monitoring in terms of LiDAR, radar, ultrasound, etc.? And then how do you, if I have your digital, if you give me access to your digital twin to do analysis as a company or as a physician, as a neurological cognitive assessment, should I keep a copy, or you're going to say, no, this is me?
Yeah, so got so many things to unpack in a few minutes, but I'll share this. Since I work for a space company, Phantom Space, we are working on cloud data centers in space. Now think about that. If I could give everyone your data on your phone, and now give you a direct access to a data center, not OpenAI, nothing AI, it's where it's doing edge computing and processing and coming back. Think of all the possibilities of what he's doing. And then to answer your question on the digital twin, who owns that data? If we can create some kind of blockchain system that allows you to keep it on your device, process somewhere else, come back down. Now we've created this independence that we're wanting. Number two, as far as what the future holds, the nice thing is many companies are doing this progress, and I'm really anxious to see what the Dubai area is doing, the Middle East and Singapore, because they're really pushing hard on this, creating digital twins, putting it inside your EMR so that it's already one platform and it's being pushed down from the government to one all the way down. What I see coming in the future, I really see, I love voice biomarkers. I think that is going to hit hard, and I'm really excited. I'm actually looking at training some of my own data so I can come up with my own algorithms, because that I think that'll be fun. But big picture, the one thing I want to say, it's all about the patient. What can we do to help that person? And if we can save lives and create the thing where we're preventing things before they actually happen, we have made an impact in humanity.
Again, Nayan, so grateful to you again. We're going to meet in person, hopefully all four of us together here in Dallas, or I would just definitely come and meet you to see where we can collaborate, and then looking at clinical paradigms, clinical trials, IRBs, all of that. And then, and of course, I'm grateful to the audience and my besties to join. Thank you so much. See you next week.
Thank you.
Hey, thank you.